Hello, it is November 27th, 2023, 10:10 p.m. As you can see, I'm already looking at the editorial already. So, tough question today, but um, if you like, if I just thought it out, it's just the usual dynamic programming problem. I believe for this one we return ants. Okay, let's try this. But so today's problem is called night dialer, and what we do is we have a dial pad like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We ignore the asterisk and the hyphen. Wait, that's not a hyphen. That's a pound sign. Yes, we ignore it. So there's only these 10 um these 10 blocks, and we have a night piece, and what we're doing is we are returning the number of possible movements, or actually, what are we trying to return? Possible movements. Given them how many distinct phone numbers of length n? Okay, yeah. How many distinct phone numbers of length n we can dial with this? So what we do is we have so for example, if the n is 1, then we could touch every key, and that means we if the length is 1, we can only have 10 distinct combinations. And note that we are note that it's not just a simple permutation problem, because some of the notes the knight cannot touch. Like, we can't get 9 9 because it can't jump to the same spot. And if you don't know already, a knight moves like a 7. So let's take this box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Let's say a knight was here. It can move here, it can move here. And you'll see that from any box, there's only 2 spots that it can move to, realistically. If that makes sense. And some spots there are 0, like right here. It's unable to move to any. And that is how we implement it in our dynamic programming. We have an array of jumps, possible jumps. Okay, well, this one can jump to, from 4 you can jump multiple. I guess you could jump to 3, you could jump to 9, you can jump to 0 as well. So that's kind of an edge case, as well as 5. And that is the possibilities of jumps. And that will also be the possibilities of the numbers combinations that we can make. And with most dynamic programming problems, we also have a memo. This keeps count of the this keeps count of the combinations, I believe, and we use this to recursively jump through all the combinations and figure out how many we can make. And in the final solution, we have we set up n as the size. We set up the memo size as well. Okay, so in the dynamic programming problem, we can see here for int next in jumps of square. So we know which square we are at right now, and we want to iterate through all possibilities in the possible square. And that is how we recursively increment our answer with this jumps array. And with this memo remains square is not equal to 0. This this shows us that it's not. We've already found the combination, I believe, and that's why we want to return the same thing so we don't recount it. Otherwise, we want to increment and return um, the new, and the remain -1 shows us how many more steps we kind of can go to based on the size. And yeah, I hope that clears up this dynamic programming solution. It's kind of late. I had a lot of work today working on this discrete video for my discrete class, but it's pretty much done. Um, yeah, thank you. I'll see you tomorrow. Hopefully, we'll be back on the no copying grind, but um, I'm feeling like I need to be more. I think I want to work on some projects as well soon. So I don't know how long I'll be keeping this Leetcode streak for. Maybe I'll also do some of uh, the problem, the courses kind of in Leetcode. Um, Let me check them out. I think there'll be an explore. Yeah, maybe some of these courses, so I could prepare for interviews. But other than that, I think I want to move on to some more interactive projects as well. Uh, yeah, the thrill. Unfortunately, the thrill of writing algorithms every day is not as fun as it is before. Um, but I think I learned a lot. It was good for discipline. I think I've built a pretty healthy habit of coding consistently, which I am proud of. Um, and hopefully I could use that in the future. So, yeah, thank you for watching. I'll see you tomorrow. Hopefully. We'll see.